There are more than 80,000 seconds in one day. What is another way to represent 80,000? All right, well, let's look at some answers here. Well, I noticed first off that this is kind of an interesting form of scientific notation. Notice the first number, instead of just being the 8, they've taken it and rewritten it. So let's see if we can get any of these to equal that first 8 that we've got there. So let's see, 4 to the second, well, that's 4 times 4, that's 16. Well, that's certainly not 8. So C doesn't work, D doesn't work. It's going to have to be one of these. So 2 to the third. So let's write that down. So 2 to the third, that is 8 times 10. Well, let's see what power we would have to go with. So our not our exponent, our decimal is here. We need to put it there between the 8 and the 0. That's 3 positions plus 1 more makes 4. 10 to the fourth. Sure enough, there it is. 2 to the third times 10 to the fourth. That makes sense. B rather, unfortunately, goes too far. Makes the number just too large. So A is our answer there for number 20. All right, I think we only have one more page to go. Here we are. Number 21, operations here with scientific notation. What is the product of 5 times 10 to the fourth and 7 times 10 to the negative second expressed in scientific notation? Now remember, I showed you all how to use your calculator, so I'll do that with you real quick just to remind you that calculators are allowed on the exam, so if you'd wish to use it, go ahead. Now notice it does say product, which means we're going to multiply these together. So 5 second, our double E button there. So 5 times 10 to the fourth multiplied by 7 second E. So remember that means times 10 to the negative second power. Now notice my calculator's not in scientific notation. Notice our answers are. So if your calculator's like that, remember hit second, your DRG button, go over to science, hit enter, and it'll change it out for you. So I'm looking for 3.5 times 10 to the third. Well, that's to the fourth, that's to the fourth, that's to the negative first. B is the only one that makes sense. The first factor there, 3.5, is correct, and we've got our third power. So there we are. 21's answer is B, 3.5 times 10 to the third. All right, let's take a look at the next one. Earth is about 9.3 times 10 to the seventh miles away from the sun. Pluto is about 3.6745 times 10 to the 9th miles away from the sun. Notice that's 2 whole decimal places that are separating them out. That's huge. About how much further is Pluto from the sun than Earth? Well, let's look at our answers. How much further? Well, if I was going to ask that question, let me diagram this. So let's make this be the sun. There it is. Beautiful sun. Here's us. We're the Earth. I'll label it with an E. And then way, way out here with a P is Pluto. All right. So it's asking how much further is Pluto from the sun. So if we were both, say, at the sun, and terribly crispy at this point, but if we both started at the sun and I traveled to Earth and you traveled to Pluto, so here I am, I'll go from just here to here, and if you go from here all the way to here, what we're trying to figure out is this distance from Earth to Pluto. How much further? Well, to figure that out, all we'd have to do is subtract. So we'll take these two numbers and subtract them. Now, remember, Pluto has the larger value, so we're going to use it first. So clear that out. So we'll take, what is this, 3.6745 second E to the 9th, subtract 9.3 second E7. Now remember, when you're adding or subtracting with scientific notation, typically this, the larger exponent, is the one that our answer will ultimately be in. So let's hit enter. Oh, what did we do wrong? Oh, I see what we did. Notice, I typed in 9 when it should have been a 7. So let's change that, a 7. Because my answer, you noticed, was a negative number, and that didn't make any sense in our situation. So be sure that you check your calculator in case you miskeyed something, which I just did. So let's look. Our answer should be to the 9th power. Well, negative 2 doesn't make sense. 2 certainly doesn't make sense. 7 doesn't seem to work. Notice D is the only answer that seems to make sense here, 3.581. So notice all the digits match up, plus 10 to the 9th. So D is our answer there for number 22. All right, next question. Number 23. Each quart of air contains 7 times 10 to the 4th molecules. The average person breathes in 1.6 times 10 to the 4th quarts of air per day. Use the following expression to find the approximate number of molecules a person breathes in one day. Goodness gracious. So all we got to do is multiply this out. Now, real quick, you can use, of course, your calculator, but remember, if we're multiplying in scientific notation, one way to work through this is to simply add our exponents together. Well, notice I got 4 and 4. That would get me 8. Well, if we're getting 8, that means 17 is entirely too large. So let's mark that out. That also means 5 is entirely, well, not large enough. So let's mark that out. So it's between B and C. So what I recommend we do is we multiply through and see which one of these final answers makes sense. So 7, second E, let's see, what is it, to the 4th, times 1.6 second E to the 4th. Let's see what we get. What do you know? We get to the 9th. In this case, if we multiplied 7 and 1.6, we would have ended up at 11.2, okay, which is fine, but not for scientific notation. So when we move that decimal over, we add one more there to our exponent, so we should be to the 9th power. C is our answer. B is not. All right. 2 more to go. 2 more to go. All right, number 24. Last year, 624 million telemarketing calls replaced by 36,000 A&J Communications employees. Good golly. Which expression determines the average number of calls placed by each A&J employee? All right, well, let's think about our question. There were 624 million telemarketing calls. All right, well, let's box that in there. That's important. And they were placed by 36,000 A&J employees. So if we wanted to see what just say one employee did, assuming they all did the same, we would simply divide out. Well, notice that's all these problems are doing, are dividing out. So let's write the numbers down. So 624 million. Let's write that number down. 624 million. So comma 1, 2, 3. So that's 100,000 now. 1, 2, 3. That would be millions. All right. Let's write it in scientific notation. So my decimals here, we want it there. That's the difference of 3, 6, 7, 8 positions. So 6.24 times 10. And we said we went 3, 6, 7. It says 8 positions. There it is, 8 positions. Well, notice B is the only one that seems to have that number at the top. The rest of them to the 9th, to the 7th, to the 6th, that's too large, and these are too small. To verify that that is the correct answer, let's write out 36,000 and rewrite it. So our decimals here, we want it there. That's 3 4 positions. So 3.6 times 10 to the 4th. Well, sure enough, there it is. 3.6 times 10 to the 4th. B is what we wanted. All right, last question. Almost there. The world has approximately 1.5 times 10 to the 8th square kilometers of land mass. All right, that's a lot of land. North America has approximately 2.5 times 10 to the 7th square kilometers of land mass. How many times as large as North America's land mass is the world's land mass? Well, that's a fun question. Let's think of it this way. Let's draw a picture. So there's the world. And we're talking about North America. So let's draw us just a real kind of quick. So there's Alaska, and there's California, Mexico. Let's see, there's the rest of Canada. Let's see, the eastern seaboard. There's Florida, and the rest of Mexico. Stop. All right. So there's North America. We live about there. That is all the landmass North America has. The rest of it belongs to the rest of the world. And what we're trying to see is how many times could we put this, our continent, onto the rest of the world's landmass. So while it says how many times, this really isn't a multiplication problem. It's division. So we're going to take the world's landmass and we're going to divide it by our landmass, the North American continent, and see where do we end up. All right. So we're going to take 1.5 times 10 to the 8th, and we're going to divide it by 2.5 times 10 to the 7th and see what we get. All right, so again, grab your calculator. Here we go. We're going to take 1.5 second e, what is that, to the 8th, and divide it by 2.5 second e to the 7th. And what do you know? 6 straight up. So there it is. And if you think about it, that makes sense. There's no way 125 of our continents would fit on the rest of the Earth's landmass. It's crazy. Same as 60. Now 10. Could you fit 10 North Americas onto the rest of the continents? Well, think about it. How many continents are there on Earth? There aren't 10 of them. We're not one of 10. We're one of a much fewer number than that. So that doesn't make sense either. It has to be A, even if you didn't do the math. All right, so that gets you all of the answers to the practice test. Sorry it took so long, but again, when you're taking the test, you won't have a teacher talking to you the whole time. So that took us about a half hour to get through it. Best of luck to you on the test.